All right, let's dive right into this explainer and finally crack open the ultimate black box of large language models. Look, if you've spent any time at all interacting with AI, you've probably noticed that sometimes it feels like pure, absolute magic, and other times, it's incredibly frustrating. Today, we're popping the hood. We're going to focus on the absolute basics of AI tokens so we can understand exactly how these models read, process, and spit out language. Because it's a question we've literally all asked, right? Why does AI just completely ignore your instructions sometimes? Or why does it suddenly hallucinate some weird fact or totally forget a rule you gave it like 5 minutes ago? Well, to solve this mystery of why AI hallucinates or forgets, we have to zoom way, way in, down to the microscopic level. We can't just look at whole sentences. We need to look at the fundamental architecture of how data is actually ingested. So, here's our quick roadmap. 1. What exactly is an AI token? 2. Predicting the next token. 3. Understanding context. 4. The murky middle problem. And 5. Managing your token budget. Okay, section 1. What is an AI token? The building blocks. Let's look at the absolute foundation of how an AI actually reads. The very first thing you gotta know is that AI models, they don't read words like you and I do. Human brains process language seamlessly, but AI, it needs a completely different approach to chew through language efficiently. So it breaks text down into tokens. Think of a token as the absolute fundamental building block of AI text. Depending on how complex a word is, a token could be a whole word, maybe just a syllable, a single character, or literally just a comma. It is the atomic level of artificial intelligence. Now, once your text is broken down or tokenized, the model has to figure out what those tokens actually mean in relation to each other. It does this through a pretty wild process called positional encoding, which basically acts like a mathematical GPS location for every single token. And this is absolutely crucial. Without this GPS, the AI would just see a giant, jumbled bag of words. This exact mechanism is how the AI actually knows the difference between the cat sat on the mat and the mat sat on the cat. All right, section 2, predicting the next token, the autocomplete engine. Now that we have our building blocks, let's take a look at the engine itself. At their absolute core, large language models are essentially just super sophisticated autocomplete functions. I mean, they don't think in a human sense, they calculate. By analyzing the sequence of tokens you fed into it, alongside its massive ocean of training data, the AI simply calculates the probability of what the very next token should be. And then it does it again and again, predicting which word comes next, over and over, just to build a single sentence. But here is where we hit a massive challenge, and it's called prompt sensitivity. There is a wild amount of mathematical variance happening behind the scenes here. See, in older AI models, like the ones used for sorting images, the network would cluster similar concepts closely together. But researchers found that large language models actually do the exact opposite. They disperse them. Changing even a single token mathematically alters the model's entire trajectory. That means if you ask the exact same question, but you just tweak one single word, even if it means the exact same thing, the AI might take a completely different mathematical path and give you a wildly different answer. Crazy, right? And the implication of all that math is incredibly counterintuitive. Researchers actually discovered that your prompt templates exert a greater influence on the AI's raw predictions than the actual questions you're asking. Basically, the surrounding structure of your prompt, the formatting, the template, all of that influences the AI's math more than the core question you are trying to get answered. Structure is literally everything. So, section 3, understanding the context window, the AI's working memory. Let's move over to the environment where all these tokens actually live and operate. You can basically think of the context window as the AI's short-term working memory. It's the specific space where a model processes text, and it is strictly measured in a capped number of tokens. When you ask an AI something, it isn't just looking at your last sentence, it's juggling your current prompt plus the entire previous conversation right up to its context window limit. Think of it as your token budget. It dictates exactly how much previous info the AI can hold on to before it literally runs out of room and starts dropping the oldest stuff from its memory. And when you compare leading models side by side, you see these absolutely massive leaps in memory capacity. I mean, we started with models that could process just a few thousand tokens. But now, looking at models like GPT-4o or Llama 3.1, we are dealing with staggering context windows of 128,000 tokens. To put that into perspective, that is enough memory to swallow hundreds of pages of text in a single pass. Section 4. The murky middle problem. limits of large windows. Before you go dumping entire libraries into your chat window, there's a bit of a catch.
A massive context window isn't some magical silver bullet. It's a huge trade-off. While small context windows are lightning fast, super efficient, and cheap to run, yeah, they lose track of long interactions. But on the flip side, large context windows can handle epic documents, but they are incredibly computationally expensive. Just doubling your token count can actually quadruple the computational demand, which causes a massive spike in cost, energy, and wait time.
And beyond the cost, there's a fundamental cognitive limit known as the murky middle. Let's say you max out a 128,000 token window by feeding the entire novel of David Copperfield into an LLM. The AI, it'll grasp the broad themes easily, but it will very likely completely overlook critical, precise little details hidden right in the middle of the text. It remembers the beginning and the end perfectly, but the middle becomes, well, murky. The precision just completely degrades as you max out that token count.
Section 5. Managing your token budget. Optimize your prompts. So why does all this actually matter to you when you're just sitting there staring at a blinking cursor?
Well, because every single token matters, the most powerful way to manage your budget is through what's called a system prompt. Think of a system prompt as a standing instruction set that sits at the very top of the AI's context stack. It defines the AI's role, its tone, its specific domain knowledge, and its strict limitations, all before you ever type a single message. Instead of wasting your precious tokens repeating yourself every turn, you establish the absolute boundaries once in the system prompt, and that shapes every single answer the model will ever give you in that session.
To really optimize that token budget and get top-tier results, you need a game plan. First, use that system prompt for your standing rules. Second, set explicit negative constraints. Literally tell the AI exactly what not to do. This stops it from wasting tokens generating useless fluff. Third, provide contextual grounding so the AI anchors its autocomplete math to your actual data, which drastically reduces hallucinations. And finally, use RAG, Retrieval Augmented Generation. Instead of stuffing your window full of static text and hitting that murky middle, RAG lets the AI dynamically grab only the exact external data it needs right when it needs it.
Look, the whole thing is perfectly summarized by this one insight. The foundation of effective AI output isn't the model, it's the prompt. Whether you're messing around with an 8,000 token model or a 128,000 token beast, mastering these fundamental building blocks, knowing how tokens work, how the math scatters, and how to rigorously manage your memory budget, that is the true secret to unlocking reliable, consistent AI.
So, we've unraveled the black box. We've seen how tokens are the atomic units of AI, and how the context window totally dictates the limits of its memory. But look, understanding the mechanics, that is only half the battle. The real magic happens when you apply it. So I want to leave you with this. Now that you actually understand exactly how your token budget works, how are you going to spend it on your very next prompt?